Okay, so hello and welcome to SDC Verifier webinar. First of all, I'd like to introduce ourselves. My name is Oleg. I'm here together with Wouter Vandenbos, who is CEO of SDC Verifier. And there's also Bohdan with us, who is one of our lead software developers, and he's going to make the demonstrations and show the how to perform the plate buckling check on Ansys with SDC Verifier. But first of all, I would like to give an extremely brief and short introduction to what is SDC Verifier and how it improves your engineering experience with Ansys and how it enables the code checking within Ansys Mechanical. So we already had a few of this webinars within introductions. So if you would like to have more extensive version, you better go to our website or to our YouTube channel and find the webinars on beam checks or welds and fatigue, and there is an extensive introduction to the software. To save time, I'm going to just make a 5 minutes presentation of what is SDC Verifier. So SDC Verifier is a post-processing tool which is built on top of Ansys, which helps you to make the load combinations, recognition of structural members, because checks are done on structural members and not on the finite elements. Then we have the checks itself according to a lot of different popular industry standards, and we have the automatic template-based reporting, which helps you to generate the complete document within few clicks. So SDC Verifier is we are working together with Ansys, and it is enabled through Ansys partner program. We utilize ACD to provide the interface between Ansys Mechanical and SDC Verifier application. It can be a standalone window if you use 2 monitors, or it can be embedded into your Ansys Mechanical window. This is the circle of workflow with SDC Verifier. So we take your finite element model, we do the combination of loading, we do the recognition of structural members, then the checks, and then the automatic documentation. And the idea is that everything is stored and it is template based. So if you already have the report and you need to do some update, you don't need to repeat all the steps. You just update your model and regenerate the documentation. We work in offshore, oil and gas, and maritime, civil engineering, aerospace, and heavy equipment. A lot of standards for these industries are implemented, and we are constantly growing this database, and we are adding new standards. At the end of my introduction, I will show the new features of the next version of SDC Verifier. Calculation core of SDC Verifier will be explained by Bohdan. We are able to combine the single load results into linear combinations and into the load groups, which is showing the maximum result on the set of results. And we can combine huge amount of loads automatically. Then we have the load handling tools, which are helping to post-process this amount of loads, to reduce the amount of load sets by selecting the most crucial one, the governing loads. We also have a peak finder tool, which helps you to show the maximum results on the model, not to miss any hotspot or overshoot. So basically, we take your FEA model, we do the combinations, and we post-process the result of the FEA model. Then we go to the recognition section. SDC Verifier is capable of automatic recognition of joints, of beam members, of stiffeners and plate fields, and also of welds, with setting the different parameters for welds. This is extremely helpful, for example, for offshore industry. By coordinate, we are capable of recognizing the frames, decks, and longitudinals of the ship, and then within this, we are able to recognize the plate fields. which are mesh independent. So you can have 100 finite elements here or one element. It will anyway be automatically recognized, and you will have the dimensions of all your plates for plate buckling. Bogdan will show today how to perform this, and yes, that's why I'm not going to stop on this on details. We also are capable of recognition of joints and beam members as well. It's mesh independent. For beam buckling, you need buckling lengths, and it is not necessarily to have one element from joint to joint. You can, for precise results, you can have here 100 of elements, for example, and it will be used for the beam buckling checks. Also, joints are used to determine buckling lengths, and they're used for joint checks. This is how the beam model, beam-like construction looks after recognition. So you have huge amount of finite elements, and afterwards we are capable of recognizing the members and the joints. The crucial in this beam members recognition is the possibility to recognize the beam member lengths in different directions. For example, this beam is having in Y direction 2 members by 3 meters because of this joint here, and in vertical direction in Z it's having it is 1 member over 6 meters. This is very important for the beam buckling. We're capable of recognizing welds completely automatically. And we can convert the stresses into weld direction, which helps us to see the stresses parallel to the weld and perpendicular to the weld. After this is important for doing the weld strength check. So we've covered the recognition. Now we go to the checks. We have a lot of popular standards implemented. For beam members, it's AISC, API, Eurocodes, ISO. For fatigue, we have FEM, DIN, Eurocode 3, EN. For plate buckling, and from new version for the stiffened plates buckling and stiffener buckling, it is ABS and DNV. And the biggest benefit is that all the checks are open. You can see the formulas, you can modify it, you can write your own. For example, for AISC standard here, we are having all the formulas for all the checks, as well with the description from where this formula is taken, which is from which chapter or table, or where you can find it in the standard itself. And you can also write the simple checks yourself. You can you can write your own formulas like in Excel, but using the results of your Ansys model or the parameters from your Ansys models as variables. Then we have, so for the standards, plate buckling, which will be covered today by Bogdan in a demonstration. For the fatigue, because of automatic recognition of the welds, it is now possible to set the classification for welds in different direction according to Eurocode or EN or FEM. So FAT classes can be set for every weld or for groups of weld, and it's also set separately in different directions. We've covered that in our previous webinars, so please go to our YouTube channel or website, and then there you can find a demonstration how to perform the fatigue check. Weld strength check per weld, because we can we are able to convert the stresses in the weld direction. We are capable of calculating the strength of the weld over the length. Then there is some specific custom checks like rivets and bolts, which is if you have rivets or bolts in your model modeled as beam members, we're capable to do the calculation of these members. So this was extremely brief on checks. And then the automatic reporting, which I hope we'll also have time to show you today. It is template based. It is possible to generate the report and export it into PDF, Word, or PowerPoint presentation. And it is completely automatic and helps you to present how your model is built, what are the loads, what are the properties, materials, constraints, weights, and so on. and after it helps to show all the results of your calculation and results of the check, so on. And again, it's stored, so if something changed in your model, you regenerate it in one click. And yeah, it's completely automatic. Once again, the description of the model and the results are presented like this, and for every combination. So if you created hundreds of combinations, you're capable to generate 500 pages report in minutes. So quick summary: SDC Verifier enables code checking in Ansys. We have the popular standards available, or the standards are open and can be customized, and you can write your own. The total calculation procedure is stored, so you can go back to previous, open some other model as template, or do the last minute update and it saves you a huge amount of time. And we have the extensive reporting, which helps you to generate the document automatically. You can get a trial license to evaluate the software. Just download it from our website, go to License Manager and request a trial. You can find step-by-step tutorials on popular standards or how to get started, how to create a report on our website. Also we have the YouTube channel where is short tips or tricks, or there is the previous webinar recording for beam buckling, for fatigue, for how to generate a report, for governing load tool, and so on. Our next webinar will be on 20th of November, and it's going to be on our new version, SDC Verifier 5.3, and there we will show you new features of the software, which will be released in October. Quick glance on what's going to be presented there. Recognition of stiffeners and girders within Panel Finder, which will be shown today by, so today Bogdan will show you the panels, but from new version we're going to have the recognition of stiffeners, which was very, yeah, a lot of customers were asking for this, so now it's available in next version. After that we have the stiffener check according to DNV already implemented. Then we have the calculation of effective plate width. We have the full history of calculation, which can be checked and seen. And then the important update, we are going to have the modular system. So you will be able, if you don't need, for example, the complete program and you're working with only some one direction of checks, for example, only beam member checks or plates or fatigue, you're capable to rent the SDC Verifier. You will be capable to rent SDC Verifier for 1 year with only one module, which will contain only fatigue or only weld strengths or only plate or beam checks. All these things are going to be released in October and will be shown on a webinar on 20th of November. That's basically it on the introduction. I tried to keep it as short as possible, but still I stole 10 minutes of Bogdan's presentation time. I hope he will manage to do the demonstration now. So if you still have any remaining questions, you can ask now, or yeah, you can always write me an email or give me a call. And now we're going to switch to the demonstration, and if you have any questions, you can unmute your microphone and ask, or just type it into the message box and we will respond as soon as possible. So Bogdan, floor is yours. I stop presenting and we go to the demonstration.
Yeah, okay. I will share the screen now. Okay, do you see my screen?
Not yet.
I also don't see it.
Yeah, it's sharing.
Yeah, wait a second. Yeah, it's loading.
Yeah.
Okay, good. Okay, so welcome to our webinar. Today I'm going to show you how to prepare a project to do a plate buckling check according to DNV 2010, and also prepare a report structure to present that to the customers. As a start model, I will use the part of the ship. Yes, you can see on the picture. Yeah, and just to remind how to start SDC Verifier from the workbench. So if you have the software already installed, you can find that on the left, yeah, the code checking and reporting and SDC Verifier. To link that to your model, you can just drag that on the model node, and you will get the linkage. To start SDC Verifier, you need to double click on any of the nodes here. So what I'm going to do. Yeah, and for the beginning, when you start a new project, you will see the project wizard, when you can define your combinations to fill the start info, and you will do the step-by-step settings, what I'm going to do now. So the first page is the project details, that is the general information on your project, where you can see where you can enter your project number, for example, project name. Okay, the unit system which is used in Ansys, and also fill in engineer and customer details. This will be used in the report for the start page. I'm going to load that from the library already existing. Okay, now we can go to the next step. So next step is jobs. Job is the link to the Ansys mechanical analysis. And here in this window, you can choose what analysis you want to include in your project. Next step is the load sets. Load sets is a linear combination of the individual loads multiplied on factors. Individual load is the link to the step in Ansys mechanical. So we have 5 steps in our model, and we will use 5 individual loads. You can create load sets one by one, or you can do that in Excel, for example, and copy and paste factors from the clipboard, like this one. So now I have 12 load sets, and now I can go to the next step. So load group. Load group is an envelope of results that will calculate extremes on its items. I will create one load group and include all my load combination in it, like this. So the next step is report wizard. This will open you a step-by-step report where you can define your tables, plots, and include properties, materials, and other items in the report. I'm going to skip this step and go back to previous step and press finish. As you can see, we have a tree built based on this project wizard. We have 12 combinations. We have a load group. By the way, I'll name that to the envelope. Okay. So since we have all combinations set up, before we do a buckling check, we need to perform a recognition of the plates. For this, we can use Panel Finder tool. We'll open that, press find. Yeah. You can see different types of sections, so section X, Y, Z, and custom. This corresponds to the frames, longitudinals, decks, and custom sections are the inclined or the parts of the hull, for example. Yeah. To perform a recognition, you can press the Find All button. And you can see that I have 5 frames, 9 longitudinals, and 6 decks. So each section has a constant coordinate, so that is a set of elements where all nodes are of the constant coordinate. And the amount of plates is shown here. On the right, you can see the list of recognized plates for the selected section. I'm going to plot the IDs of the plates to show that on the model. So as you can see, we have a colored plot where plates are in different colors and with their numbers on the top. Plate dimensions are recognized automatically, but if you're not happy or you want to do some calculation with another parameters, so you can modify that manually, for example 0.8, like this one. Or you can set the same dimension for the multiple plates. To see if all dimensions satisfy your needs, you can use plots features. I will select the labels with plate dimensions, and I will plot that for one section, but you can also use that for a set of sections. So I'm going to plot that for the first section. And now it is visible also that plates are all still in colors, and you have a dimension in square brackets, so you can check that over your model. Also, you can export plates to named selection, for example, in Ansys, to operate them with, or you can export also that to components. I will skip that step and we'll go to the filter. Here you can display plates by some criteria. We have a list of criteria, for example, like lengths, widths. I'm going to show you how to do that with undefined dimensions, because sometimes plate may not have dimensions recognized. For example, if you have coincident nodes or free edges, So I will check that on my model. As I can see, I don't have the plates without dimensions, so everything is fine. And now I can continue to create a plate buckling standard. To create a standard, you need to go to the standard chapter, press add, and among the list of implemented standards in SDC Verifier, you can find 2 revisions of plate buckling ABS and 2 revisions of plate buckling DNV. I'm going to continue with plate buckling 2010. When you open the standard, you will see the window where you can define the options required by a standard, and also the items that are necessary to calculation. For example, materials with yield. If you don't have, if some materials does not have yield, it will be shown here. You can also modify that from this window. So I'm going to continue with the default settings and press OK. Now you can see that I have one check. If you want to change the settings of your standard, you can press Edit here and change, for example, the factor to 1. Okay, I'm going to show you the check. So here we can see that we have 9 parameters and 28 replacements. So parameters will be shown in the table and in the plot, so it will be possible to select them. And replacements are intermediate results. Each of the formula we try to set a correct description, for example, a reference to the formula in the standard, so you can easily to navigate to that and to check what calculations are done here. So by default, the standard is built in, and you cannot modify the formulas here. If you want to do some extra calculation or modify the formulas, you can copy standard as custom. And now if you press edit, you have the editing enabled. You can also edit that by clicking on the parameter and type, for example, +1 or anything you want. Just small tips for the formulas you can find here. For example, for plates, you can use plate lengths, widths, and so on. And also for results, you can use different stress. How do you want to calculate the stresses? I'm not going to change anything. And I will press cancel. So now we have the plate buckling standard created, and we can go to results presentation. I will use another project where I already have that everything calculated. So I will start that. When you have a project saved, you can see that project wizard is not started. Yeah, and it is already automatically loaded from the file. Yeah, we have the same combinations and envelope of the results. So to present the results, you can use the plots or the tables. I will use that for the envelope. I will show the absolute maximum equivalent stress on my model and put the labels over my plates. So the plates will be taken from the panel finder tool, but probably I'm not going to show all the labels. I will set up the limit for the labels to show only those that are about the 240 megapascals. Okay, and now we can preview that. As you can see, we have a plot of the stresses, and we have labels on the plates that are about 240 megapascals. Okay, also you can use some advanced tables that, for example, if you want to see the stresses over all your combinations, you can do that in the flow table and select the load group content. It will take all the loads that are included in load group 1 and automatically add that to the table. I'm going to fill. Yeah, and now in one table you can see all your stresses on all your combination of the model. For each direction you can find the minimum and the maximum stress for each direction. Yeah. For the plate buckling checks, you can do the same results. You can use a plot or a table. I'm going to show you how to check all your sections at once. So I will use an envelope of results and press fill table. So you can find the 9 parameters that we saw in the check. So we have plate dimensions, plate stresses, and backwind factors. If you want to see only critical values, for example, the factor is above 1, you can use this setting. And I will refill the table. And now the sections are reduced, so I have only those sections critical. And extra row that will show you the section with the maximum utilization factor and the plate ID of that. If you want to display results for each plate, you can. I will pick one section, and I will use the show plate results option. Now for single section, you can find all the plate results. So the maximum plate is 25. You can also plot any value from the table and put the label on it, yeah, using this button. So I will plot the backwind factor overall. And now I have that place displayed here with the labels. Wait a second, I will show you. Yeah, with the label of the value. If you want to see the detailed calculation for each element, you can use a plate inspector tool. So if you open that, you will see first of all, you will see the info of the selected plate. So you will get their dimensions, yeah, yield and factors, and see the result for each of the element. The last column is the load. So it means if you check the buckling on envelope, it will show you the governing load. It means that the worst item from this envelope that caused this result. Okay. Next result output is governing load. Governing load tool enables you to reduce the amount of loads you want to check by showing only critical loads. You have two options here. First is from load, so you can check on your result category like stress, displacement, and so on, and also check results, for example, for the plate buckling. So I will use that for plate buckling, for example, and set the criteria that my backlink factor parameter is above 1. You can use also other parameters like percentage of the elements of the model, yeah, and so on. And change the selection. So if you don't want to check all the model, yeah, you can change that. So I'm going to fill that. And as you can find, I have 3 load sets that gives me the maximum results on the envelope. I can plot them directly in the model. Load sets are in colors. You can find the labels on the top. Yeah, and corresponding elements will be colored in the same color. And you will get the value of the most critical element on top of it. You can also directly create a load group from here, so you don't now you will not calculate the 12 load sets, for example, but only the critical. So these 3 load sets. This will reduce the calculation time. Okay, and now let's go to the report. First of all, we have 4 templates for the report. We have that empty, where you define everything from the scratch. We have a model setup report, where you have your model items like properties, materials, their masses, and so on. Results report, where you have tables, plots for stresses, displacement. Yeah, and the full that is based on the results plus model setup report. I have already predefined report that is based on the full one. So when you open that, on the left you can see the structure of your report. So that this part is the model setup. You have the properties here, materials, from loads. And this is for the result report. So you have the constant settings for each load. So they are the same for all the loads. And you can, for example, you can generate only the item you want. For example, if you want to see only the table, so you can press generate. And there is no necessity to generate the full report from the beginning. So first of all, you can check your if your number format satisfies your requirements, yeah, if legend settings are set, and so on. Also, for load sets, we have a content item that will show you what individual loads are included in each load set and what factors they use. For properties, I will show how the property summary looks like. So you will have the list of the properties, the corresponding elements on that property, the material, and the mass of the property. If you want to include something in your structure, you can drag that from the toolbox. You have all the items that are defined in the main window. You can find here, like plate buckling check, the governing loads, or your combinations. Yeah, now I think we can continue to create a structure for the plate buckling. I have already that created, so I'm going to repeat that. So the basic idea is you can create the structure based by loads, like this one, and you will have a table and a plot, or by sections that will be sorted by each section. So first of all, I'm going to create a governing load, so you can access that from here, from the menu. And I'm going to use the same as I used in the main window. The result is about 1. Okay, I will generate the item. And I can see I have 3 load sets, so I'm going to create a structure only for that one, because other loads are not interesting for me. So to create a structure, we have a special tool that calls results wizard. So for plate buckling, you can create the structure here. So there are 2 options, like I said, by loads and by sections. You can select the loads you want, so I'm going to select only my load group and these load sets. So that is 4, 7, and 8. Press OK. And for each section type, you can select a different view. For example, I have already defined it, but if you want to create that view, so you can access that from here, like here. So I'm going to select that for frame, for the longitudinal, for the deck, and for the custom section, I'm going to use the default view. And if you press OK, you will get immediately a ready structure. So that is correspond to the structure by loads. I'm going to generate you one section to see how it looks like. So now you have a table for the one section with their values and the plot on it. You can also group that. If you want to create also the structure by sections later, you can group that and, for example, select this for item. Okay, and say this is my structure by loads. Okay. If you want to create your custom structure, you can do plots without using the results wizard, like here. So here you will select also the load group and the load sets. Okay. And here are the options that you want to, if you want to include each section in the different plot, or you want to use all selected sections as one selection. So one plot for all selected sections. So I will create that for each section and create a frame view and press OK. So I have the plots included, and now I can, for example, sort them by loads. So using this option, sort tables plots and put in chapters by load. And you will get the plots combined for each load. You can do the same for the sections. Yeah, if you have a list of plots, you can do that by section. So if you want, to include that for some item from your model, just drag that here and put to some chapter you want. So I think basically that is it. If you have any question on that, please ask.
Thanks, Bogdan. I have a question. Can you, if you generate this report, can you send that to all the attendees later? I think that's interesting to see how that works.
Yeah. Okay. No problem. Yeah. If you want to just you reminded me. If you want to generate the full report, you can use this button. Yeah, and it will generate you all the items.
Yeah, so after the webinar, we will share the recording and also this report. If you have any questions, we still have 10 minutes, so you can unmute your microphone and ask.
Yeah, also keep in mind that this menu on the left, if you make a PDF or Word report, that full menu structure comes back in the PDF or Word report as well. So it can be quite extensive. You have 377 pages, but by using bookmarks, it's still easy accessible.
Yeah.
Okay. Are there maybe questions, or you can type them in, or you can. But if you want to ask something, unmute your microphone first.
Okay, I believe there is no questions then. If anything appears afterwards, of course you can give me a call or send an email. And if you would like to try, if you would like to have a trial version, or if you would like to have a dedicated demo on your own needs and purposes, don't hesitate to ask. So thank you for attending. We will send you the recording and the report, and I hope to hear from you soon. And we will have, once again, we will have a new version released next month, and a webinar in November on the updates in SDC Verifier 5.3. We will have the stiffener buckling, and we will have the modular system, which will give you a possibility to rent only what you need. Thank you, and yeah, bye.
Okay, thanks, bye.